one of the things we will worry is about the liveness of a variable. What is meant by a live variable? A live variable is such a variable whose value will be used in future. Here in future means, see, we have now several basic blocks. Say B1 is our first block and we have B6 as a last block. Say after leaving B1, a variable called X is still used in B2. That's what it is meaning. It holds a value that may be needed in the future, or its value may be read before it is getting assigned later. See, if you read this repetitively, things will be very clear for you. Then we look at the example. See, B equal to 3, C equal to 5, and A is equal to, it's a function where B into C is passed. So now we have these three instances. Say this is one place. First instruction, second instruction, and third instruction. Let us say take between line 1 and line 2. We are here now. See, between line 1 and line 2, we can see that B and C are live variables. See, why? Because values of B and C are used here. That's what it is. That's what the definition goes. A variable is live at some point. See, B is live at this point because value of B is used. C is live at this point because value of C is used here. Now, there could be some other instances also. See, here we have B equal to 3. Suppose that before calling F B into C, value of B was altered. You go for a second assignment, say B is equal to 0 at this point. Then we will say that at this point, this is not live. The second assignment is live. That's what it's telling. A value of a variable can be read before the next assignment to that variable with a different value. So a value assigned to a variable should be live, and that value can be used at a second time. So suppose that in basic block 1, we assign a value to say X, and that assigned value can be used as say in basic block called 3. We will see that right from basic block 1 to basic block 3, we have to retain the value of that variable. Retaining where? Of course, when a variable is stored, it will be having a memory location. There is no question of disappearing from the value from there. But suppose that this value is in a GPR. Should I keep value of X in a register or not? If it is live, depending upon the liveness of a variable, then compiler can take a decision whether that value of that variable is to be kept in a register or not, visiting from blocks to blocks. So that is why liveness of a variable is important. See here the third statement. Value of variable A is not used. See, we say this looking at these three statements. There could be other statements in our code that make use of A. So value of A is not used here. Perhaps it might be a dead code. We don't know. but till point A is not used. Along with variable, so once a liveness of a variable is done, we can determine the next use of that variable. Why these two are important? Because if a value in a variable is used repetitively in the subsequent blocks, then there is a next use for that variable. Wherever a variable is having a next use and if it is live, then if the value of that variable was kept in a register, it need not be allocated to another variable. That is the use of next use information and liveness analysis. And now we speak about these two facts with a simple example. See, liveness analysis and next use computation is not an easy task. People have developed algorithms for this because depending upon the source code written by a programmer, this will vary. And this analysis is to be done live on a code that is not known before. So all we will decide is whether a variable is live on exit from a basic block. Now we know the importance of a basic block. We'll take a sequence of statements instead of a single statement. Then, depending with respect to a block, what is happening, whether it is live or not. And that is the analysis that is being done. So we can go for the formal definition now. What is next use? So in next use, we will worry about when the value of a variable will be used next and how it is being done. See, yes, this statement taken as such from our prescribed textbook is a different way of telling what we had done in our previous slide. If a statement J has X as an operand and control flow from statement I to J along a path has no intervening assignments to X, don't worry about this. That's what we had termed in the other slides. See, we have an assignment called as X equal to 3, say in statement number 3. And from statement number 3 to 7, there was no other assignments to X. That's what it is telling. So once we make an assignment to say a variable called as X, and till the point it is not reassigned a value, we will see that previous assignments is in use. So till that point, we will say that X is live. We will go back to our example here. B equal to 3 is an assignment. And we see that after B equal to C, B equal to 3, C equal to 5 is given. And the third statement, F B into C is called. Here we see that value of B and C are used immediately after the first assignments. There was no intervening assignments between B equal to C and A. Suppose that if there was one more assignment, say either for B or C, we will see that B equal to 3 is no more in use. That's what it is written here. And this is written or expressed in a simple way in these two sentences. So when we have such an arrangement, we will see that X is live at statement number I. This is how next use and live variable analysis is being done. And this is the algorithm for computing whether a variable is live or not. C input is a basic block B of 3 address statements. And output, at each statement say X equal to Y plus Z in a basic block called B. I will be attached to liveness and next use information of X, Y, and Z. That means we can see that value of Y and Z are used in the statement called as I. This information will be tracked. Now, how the iteration occurs? For every basic block B, we start with the last statement in that block. Then scanning is done backwards to the beginning of B. You can see that we can check about the liveness only when we go backwards, because X equal to 3 can be an assignment under the first statement. At the fifth statement, there can be an if statement using this X, but we don't know whether X was modified after the first assignment. To check that, we will have to start from the last statement in B, then we will scan backwards to the beginning of B. Then we will see that on each statement I X equal to Y plus Z in B, we will do these 3 steps. See X equal to Y plus Z. Once we see the statement, we can see that Y and Z are in use in this statement. So attach statement I, the information currently found in the symbol table regarding the next use of X, Y, and Z. Also, here we'll set that X is not live and no next use, because we don't know what will happen to X. We can see that Y and Z are in use. We don't know what's happening to X. Whether X will be used or X will not be used, that analysis will be done in the next block. And the symbol table, we will also say that Y is live. Why Y and Z are live? Because Y and Z are used in this statement to compute X. Now, whether X will be in use later, that fact we don't know at present. So at this moment, we'll say that X is not live and no next use for X, whereas there is a use for Y and Z. So this is how we will compute each and every statement in a basic block, and corresponding entries for next use and liveness will be added in the symbol table for each variable. These values will be used to judge about the liveness of a variable at any point in the program. Looking at the basic blocks.